All right, so welcome to the second part of the tutorial how to process the images acquired by Siemens Invion platform. So in this case, we'll be looking at the computed tomography images and analyze using the Slicer3D software, which is available free for Windows, Linux, and Macintosh. So in the last part, we converted the files, the header and binary file, from the format which was output by the Siemens system, and we converted into the format that will be, or it's read by Slicer3D. So let's, so I have it here in the folder on my desktop. So let's open up the Slicer 3D and so after the application will open, so this kind of familiar screen with a 3D kind of visualization box, and also at 3 plane images, so the axial, sagittal, and coronal. In the first step, we'll load in the raw data, we'll look at the data, and then we'll try actually to reduce the size of the data by cropping the image to focus on the organ or the image that we'll process in the next step. So first we need to load the data. So this is a button over here, or we can also use the button on the in the menu. We need to choose the file to open. So let's me choose go to my desktop and then to the raw data. And now we need to point to the header file that we created in the previous step. So remember, the tomographic images will have a text file, which is a header, and also the binary file, which will contain all the information on the image. So let's first open the NHDR. It will tell us in the description that it's a volume, so it knows how to read the file, the binary file, and click OK. So we need to take some time. Typically it takes several seconds to load in, but depending on the size of the file, it may take also a couple minutes. So we have right now the opened file. So this is a mouse hind limb. We can go through different planes. So we are right now going through the axial plane. So this is another one, the sagittal, and also the coronal. So as you can see, the majority of the image contain actually the area outside the limb that we are trying to analyze or to do something with that. So therefore the best idea it will be first to crop the image. So crop, by cropping I mean by just focusing on the tissue, bones, and to remove everything outside the organ of interest. This will reduce actually the resulting file size, and also speed up the process to load and save the data. So also what we can do, because right now we will be not doing any 3D visualization, so we can, using this button over here, change actually the how the data will be presented. So instead of the conventional widescreen, which has this large 3D rendering box and those 3 smaller plane views, I would go to choose the 4 up, which means that this kind of rendering window will be smaller, and the other will be much more better visible. So we need to crop it. So what tool we'll use? Well, first we need to select the module for cropping. The best idea it will be to click this kind of search button and start typing crop. After inserting first letters, so we can see the module which is called a crop volume. So let's open it up. It opens up now the crop volume module, which will allow us to define the region of interest to crop selected region of interest from the big volume. So how we start, so at the very beginning, let's start to identify the region of interest. So let's click fix. So after we click fix, so the computer would choose some arbitrary region of interest. And right now we can, using those kind of tools here, or I don't know how to call it, those elements on the screen, so we can reduce the size of the region of interest. Let me just click here like this. With this slider here, so we can go through all the planes or the slices, and it's very important to select a size of the region of interest for cropping that all the tissue will be included. So that's why we need to go through whole data set. I'll probably increase a little bit on this side. There you go. Yeah, and the rest is pretty good. All right, so right now, so this part is done. So let's do now the Z direction. So we can see that right now the region of interest contains all the tissue, but still we have place to reduce. So we can reduce size here, and then let's look what will be from the top. Oops, just gonna click that. Here you go. So that looks pretty good now. Can maybe reduce from this side as well. Here you go. And this part is actually, so we defined 3 dimensions, so X and Y, and this is Z direction. So this will be definitely within the region of interest. So we don't need to modify anything. All right, so we created a region of interest which contains the tissue of interest. So we can crop, right now we can click actually apply to crop and create a new volume which will contain only all the data within this region of interest. So let's do this. So after clicking apply, now it will take some time. Again, depends on the size of the original data file, on how fast the computer is, how many memory the computer has. It may take from 10-15 seconds to maybe a minute or two. So I will speed up this process here. It will probably take a minute or two to finalize, and I will be back in a moment. All right, so after about a minute or so, so the data set was cropped. We can see this on the image that the data set was cropped to include only the tissue. So let's look actually if we can create a 3D rendering of this data set. So because we'll be looking at the 3D volume right now, so let's make it actually this volume bigger. So let's go back to the layout. I would choose conventional widescreen. So which means that right now the box which our rendered image will appear, it will be much bigger. So we need to switch now to the module. So we created, so we got the cropped volume. By the way, the name it will be called file name cropped. And let's go to the other module, and I know what's the name here and how to find it. It's called a volume rendering. So let's select that. Let's choose now what type of data set we will be rendering. So not file name, but file name cropped. So the already prepared data set. And let's choose the preset. So this will be, let's say, so there are several presets for the tissues for different type of rendering. I would choose the CT bone, like that. Then within the rendering engine, the default is the CPU, which means that the CPU will be used to render the 3D image. However, if your computer is equipped with a good graphic card, I would prefer, or I would recommend, to change into the GPU rendering. It's much faster and the quality of the images is great, much better. So let's do that. And just to see the volume, so we need to unclick or click this kind of closed eye to open eye. And we see that we have something over here. So let's zoom it in and maybe center it by centering, so we can click this tiny center button. Excellent. So we see the tissues and the bones, but we really are interested only in the bone. So using this shift here, going to the lower values means that we'll increase the contrast to include actually the tissues. On the opposite side, we will increase the shift so we can reduce and to visualize bones only, like that. So now we have a 3D rendering of the hind limb of the bone, that we can create a picture, or we can just save the whole data set, which we'll do right now. So before going to the processing of the images using different segmentation techniques, so let's save now this data set. So when we click the save, so it will open up the window with several of the images or of the different files, which will be saved to the directory that will show. So because all those files are kind of related to our original file name or the raw data, so let's choose that they will be recorded in the same place. So go to the desktop, raw data, where we keep everything, choose. So all those images will be actually saved in the desktop and raw data folder. So now what are those additional files? Well, so for example, the scene that we see over here, it will be recorded. We don't need to record this, but let's keep it everything. The file name NHDR, so this header that we created to read the file, it didn't change, so that's why it's not checked. We have it already. The file name cropped, so this is a cropped volume right now. So definitely we want to save that. So this will be the file that will open for the processing. As you can notice, it's actually different format. So it's NRRD. So we will need just only this one file to open with the slicer. We don't need any header file or any binary file, because within this file, we have both the header and the binary as one file. And there are several other kind of additional files which at this moment we will not discuss. So when we click save, so the files will be saved. It also takes, depending on the size of the data set, between several seconds to even a couple minutes. So let's wait until the window will disappear, which will indicate that everything was saved. And we'll look at the folder, the original folder, if all those data files been saved. All right, so the window closed, so all the data set was saved, so we can close the slicer now and go to our raw data, where we can confirm the presence of those files that we saved. So this is the whole range of different files, but really most important, what we created right now is this file name cropped, which contains the cropped volume, with the unRRD, which contains both the binary information but also the header information. So this is just only one file that it's really needed for Slicer to open the cropped volume. As you can see, the size was also reduced because we cropped a lot of unwanted volume just to focus on the tissue. So it went from the original file. Let me see where it is. From, I remember, 3 gigabytes to, or 3.5 gigabytes to 500 megabytes. So 7 times smaller volume data file. All right, so that concludes actually the method for cropping the data sets. And in the next, the final step, we'll perform some type of analysis.